But I might forget that I'm recording it, and that also happens as well. Generally, I forget things. Okay, so working with APIs, I guess we got to start actually from even sort of, I guess, further back, and talk about what an API is to begin with. So let's get some audience participation. Can you jump onto this mirror board and give me your best description of your current understanding of what is an API? What is an API? When someone says there's 3 letters together, what do you think? So some of you are expanding the acronym to its 3 words. What is the follow-up question to that is what is an application programming interface?
And tell him I'm hot. Can't do this.
No, you should.
I can hear one of you, many of you, some of you, I'm not sure. I've just muted you.
Ed?
Yep.
I don't know what I've done, but I think I've like pulled my back somehow.
Oh, are you okay?
I'm okay, but every time like I turn to the side, I'm in immense pain.
That doesn't sound good.
I'm just gonna take like 5 minutes.
Yeah, absolutely. Yeah, take the first priority is yourself, all right? Let me know how you are. Cool, 1 more minute. Get any of your definitions down. Okay. So let's have a quick read through some of these. Used for allowing you to get post data from to a database / server. There's lots of support slashes there. It interacts with another server. Software that allows 2 applications to talk to each other. An application programming interface. This is the each of those 3 letters. API. Yes, application programming interface, which allows applications to talk to each other. It lets you communicate with another program, even if you aren't speaking the same language as that program. It's like a thing which connects you to useful information to use in your code. It's like a thing. I like this one. Connected to other software applications. Can import external data to interact with our program. Used for linking your application to a third-party application. A gateway to other piece of software or a service. Application program interface, a way in which we can interact with other programs to retrieve information, generally from some kind of database. Cool. So the thing in common is about for most of these things is essentially a way to communicate or get data or get things from another place. And that's a really good first step to think about an API. Now we're going to use the understanding or definition of API this afternoon in a narrow context, but in general, an API, mostly think about that last word, an interface, because we can use APIs in a vast number of ways. But the most important thing is, what is the interface, or what is the interface to the thing that we want? So a language has an API. When you use Node.js, the API for Node.js is all the functions that come with the language, all right, the standard library. That's the way that we can interact with Node.js. So if you think about any system, let's say, for example, I'm going to go down here. This is the thing that we want. This blue line represents the interface, or we'll describe it a little bit more. This is what we want. This is us on this side. And on the right-hand side is the system that we want access to. So for example, this could be a language, in which case, in order to use Node.js, we can use some of its functions like it exposes to us the process object. That's part of the Node.js API. All right. In order to use a process, we have to, in order to use anything about the process, we call the process first, and then we can say, what is a property.env, what is a property.standardout, whatever thing we want. This is part of Node.js. Equally, we can use functions on the array class. They're also part of the library if we want to interact with Node.js. So we have one way we can think about an interface in terms of what is exposed by the language so that we can use. All right. So thinking about the two sides of this line here, we're on the left, and we have to think about how we interact with the thing on the right, and the language is one of them. And there is a few things we can use from it, most of the standard library. And this is the interface. This line is the interface. It exposes specific points that we can interact with it. We can't like go in and mess around with exactly how the process object works, but if we want to use it, we just call process, and it returns to us everything that Node.js has done behind the scenes for us. So an API, again, try and think about it in terms of what the interface to a system, and that is the interface has been designed for us, all right? So whoever created Node.js has defined the interface, has defined their API about how we're going to use the language. We can do this in a few different places. So you can also think about, on an even more micro scale, what is the interface to your a certain class that you've written. How am I going to use this class? All right, you're going to define specific methods that are public for use for other people to use. So if you go about thinking about your class, you can be like, well, I only want 2 methods, and so this will be method A, for example, and this will be method B in my class. So the interface to my class is method A and method B. This is the way I can interact with my class. It's the interface to this object. So here we go here on the left again, and we can talk about the interface to this class. So API is a word, is a phrase that is used as a general idea to think about what is the interface, what's been exposed to people who want to use it. A few of you mentioned about some kind of database or talking to each other, getting from databases, interacting with servers, and it's exactly in the same way. So we have a case where we have a user wanting to interact with some data, and the right-hand side, there's going to be a server set up to handle specific requests, and this what's been exposed to us is what we call an endpoint. For example, some of you might have already done it in the thermostat challenge. We can send a request to a certain endpoint in the form of a URL, and we get back data. If we want to interact with our API, we have to know which endpoint to use, and the data is going to return back to us. And over here on the right-hand side is a server that usually is wrapped around some kind of data stored in a database. And we'll talk about the connection between a server and a database, not next week, but the week after, or maybe even 2 weeks after that. So the person who designed this over here has said, okay, I'm going to run a server, make sure there's some available endpoints for people to use to consume some data. And when they do, they send a request to a certain URL, they'll get back some data that we provide them. And it goes into the database and gets things out. It doesn't always have to be a database. There can be different ways to store data. But in the same way, all these 3 different scenarios are the same. All right, they're thinking about whoever's designed the system, whether it's a language, a class, a server, or a bunch of other things. They've done it with some intention and said, this is how you're going to interact with it. This is the interface. And we call all of these things APIs. All right, what's been exposed to the thing that you're going to be interacting with? How are you going to use it? So in the context of this work, this workshop this afternoon, we're going to be thinking about APIs in this last part. All right, this one here. The only difference here is when people talk about APIs, this is generally what people are talking about in this last one. But APIs are always used in lots of these different scenarios as well. All right, so that's why if you see APIs popping up, that doesn't necessarily mean it's about getting data from a server somewhere or from a database. It's because APIs are just simply a generic term to describe what's been exposed by a system that you can interact with. All right, that make sense? A couple nods. Let me pause here for any questions. Okay. In this afternoon session, we're going to figure out how we can request data from an API that is the Open Weather API. So we'll send a request using HTTP to send a request, get some data, and then display it on our web page using JavaScript. In order to do this, we need to be able to know how to send a request. All right, and we've been doing this in a couple of different examples using the get method from jQuery, and that's what we'll continue to do. So that part we have a little bit of experience with, but we'll have a look together again about how to do that. Now, if you haven't already, we've got to figure out how to make a successful request to this API. Now, APIs that you communicate with using HTTP to get data from should be well documented. All right, so we should be able to go to the API and see how do we send a request to get the data that we want. Once you've got your account, you can go to this API tab on the nav bar at the top, and we're going to have a look at this current weather data endpoint. There's a few different endpoints you can have a look at to get different data. These have all been designed by the Open Weather people about how to use it and what data they're going to get back. So you can click on this API doc to get more information about using this particular API. And this will give you examples of how to use it. So let's have a look at an example. We're going to have a look at the first one about how to send a request. So there are a couple things here to have a look at. One is this whole query. All right, so let's have a look at this. Now, can you see that there's a question mark in this URL? This question mark denotes the beginning of what we call the query string. All right, it's a set of key value pairs. You can see there's always the key first, an equal sign, and then there's a value. Then we separate key value pairs by this and sign. It has got another key value pair, app ID, and then you're meant to put in your own API key. So if I want to send a request to this endpoint to get the weather, I have to provide it at the moment a key of Q with a valid value, a city name, and also an app ID key with your API key. So in order to find your API key, you should all have already registered, and you should be able to go have a look at your API keys, click on your profile, and have a look at your API key, this thing here. If you haven't got one, you can generate one and create one. All right, so you should have some random string of numbers and letters that will identify you and your account to this API. It contains a whitelist of API keys. It does a check when you make a request to say, like, is this key valid? Otherwise, you can't access this service. So make sure that that is available to you. So this is part of the way that we're going to send a request. We have to pass in the city name and an app ID. A tool that you can use on your in your command line is to begin with, you can use a command line utility tool called curl. This allows you to make requests from your command line. It's quite a simple one. We'll have a look at a couple. It's a command line client that can send a request in much in the same way that your browser can send a request. We can not worry about having the whole browser have to do this for us, so you can just run it in your command line. It's as simple as using curl, and there's a number of different options. There's a bunch of different ways we could use it. The simplest way is by default, we'll send a GET request, which is what we want, and we just pass it this URL. So I'm going to grab it all for the moment, and I've got to replace some of these values here. So city name, let's do, for example, what is the current weather in London? Let's try London. It might have to be capitalized, who knows, we'll have a look. And then I've got to also share my API key. So let's go grab it and throw it in here. So I just hit enter, sent the request, and I get back all this lovely, lovely text. And this is the result of my my request. So visually, if we go back to here, in terms of how I've used the endpoint here, on the left here was like me using my command line client send a request. I send a request to a specific endpoint, the /weather endpoint, to get the current data. I sent across in my request the city name and my API key. There's a bunch of stuff happened on this side, which is all open weather stuff. Open weather is in control here. It goes and fetches information maybe from a database. Who knows how they do it? And then sends me back that data. And so this is what I got back, this stuff here, this data. So that's all just what happened by using curl to send a request to this location, to this address. It's not necessarily the most neatly formatted of formats. So a couple of things we can do to sort of be able to read it better. One is we can use a different command line utility tool. We could use one called HTTP, I think. So you might have to install this one. If you're on Mac OS, it might be as simple as just doing brew install. If you're on Windows, I'll have to go find out the installation instructions, but curl should come by default. If we execute the same thing with HTTP, we'll be able to see a nicer format here. And we can see from me initially sending the request, it gives me a bunch of information about the original request. We don't have to worry about any of this, and we'll talk through what requests are and what responses are in a couple of weeks' time. So all you need to do really is just like whack this into your command line and see what happens. And this is the response. It's better formatted so we can actually read it a little bit better. This is sent back by the server responsible for this request. And you can see it's in a specific format, all right? We call this format JSON, JSON. Now, I'll put this on this board here. There are different formats that responses can come back in, all right? And the server is sending back JSON. It's just a way to add or have a format for data so we can send data from any kind of application. It's agnostic to the original language that handles the request on the server side, and also agnostic to the language on the client side. JSON is a data format that we can use to send data to different places, right? And it's by convention quite popular as a way to send data and also manipulate it. So we can see in the response here is a bunch of key value pairs. Key on the left, or on the right hand side is the value. And it looks very similar to JavaScript, but there is a difference in it. So here in this response, we can see this is the data we get back from trying to get a request for what is the current data or current weather in London. Lots of things here. Description, overcast clouds. I reckon that could be hard-coded. Who knows? Because London is always overcast. I imagine it's not. Thank you, those of you who chuckled at that. And we get a bunch of information, and this is a successful request and response, all right? So how is this going to help us? Well, the first thing we have to do is just be able to make successful requests, all right? So I'm going to give everyone 10 minutes just to make sure we get to the point where you've been able to make a successful request to the open weather API, the current weather, this one here, with the first API call, all right? And do it from your command line. Make a successful request before we can move forward. Sound good? All right, 10 minutes. It shouldn't take you that long, but some of you might encounter some bugs and things like that. So let's do 10 minutes and be back here on the clock. Stick around if you have any questions or thoughts, all right?
Wait, so are we just going to do what you've just done?
Yep. Please make a successful request to the Open Weather API, this one here. And put in any city that you want. Maybe imagine what it's like in, I don't know, British Virgin Islands, Mauritius, Mount Everest, that's not a city.
So I don't look stupid.
Great. Okay, thank you. Thank you, Grant, for so we're going to have a look at this very simple domain model. Given a user, when they visit the homepage, then they see the current temperature. And this is the application I want to build. And the interaction I have is I simply navigate to the index of my application, and I want to see this text on the screen. So the first step that I want you to do is you'll have all of this in your cloned version of the repository. Make sure it's up to date. There's always new things that get added to it. So make sure you have the most current version of it. And the way that we're going to set this all up is just look at the instructions. So let's double check And close everything to make sure we can all do this from scratch. Okay, so in the first terminal shell that you open up, when you navigate to this directory, the first thing you should always do is install the dependencies. The list of dependencies is simply just Cypress and HTTP server. And actually, that really should be the development dependency, not in the actual. All right, anyway. So we have 3 dependencies: ESLint, Cypress, and HTTP server. HTTP server is the same thing as, or does almost the same job as one of the other dependencies we've been using before called serve. It just helps us run our application on a local server that we can interact with it. All right. The way we use it is just by doing npx HTTP server. So let's now run that command. And it gives us some information saying, starting up HTTP server, serving the index. That first dot is the current directory. So everything in the current directory. By default, it will try to find the index.html at the index. All right, so it tries to load this HTML file first. And then it says it's available at this address. This is the common IP address and sort of your private IP address within your machine as your local host. So you can do the same thing. You can whack this into your command line or your browser, sorry, and we are here. You've seen a few different ports that we've been using. We've been using maybe 5,000 for some of them. There are different ports that are available, so just always make sure you find the right one to use. All right. So for this example, we're going to be using 8080. There is some default ports. You can always specify a port if you want to do, but let's not worry about that until a couple of weeks' time when you dive more into web stuff. We were following the instructions. For setup, we're in the right directory. We installed dependencies and we've run our application, and we are now in our browser at that address. Now, as running, we can open up Cypress. So you always have to make sure you're running the application first. So in the second window, let's run Cypress. This is all things that we've done before, so this should be fairly straightforward for everyone. Move your faces out of the way so I can actually see this window. And this is the spec that we're going to exist in for the first part of this. Let's open up. We'll have absolutely nothing in here. I think actually there was something in here. Have I just deleted everything accidentally? Let's double check. Oh, it's just an empty assertion. Cool. Okay, so we've gone through the setup just to run tests. And this is what I want everyone to do. So the main point of this exercise is to find a way to not actually send the request in our test. Right? Think back to the other a workshop that we did last week about not sending that message using Twilio, right? Using a third-party external library, we found a way to mock it. And we're going to do something very similar, at least the approach is very similar. We're going to intercept the request that gets sent to the OpenWeather API, and we're going to say, don't actually send it, and return some of this data that we have when we store ourselves. And so we're going to essentially fake the call, the API call, and return our own data instead. All right. So we call that using a fixture. All right. The response that we fake is what we call a fixture. But before we get to that part, let's write this feature test to make sure we're on the right track. So I'm going to not keep that pending. We're going to remove that X. And I'm going to write my feature test. I think it's bigger, so we can probably see it better. When I visit the home page, I see the current temp. In here, I'm going to use my visit command to say, let's go visit the index. And then I want to make an assertion that says, what does my app look like at the moment? Let's just use this element, the app. So let's get the app element, and then let's make an assertion that it should contain, what does my domain model say? Where is it? The temperature is 21C. All right, this is my feature to say when I visit my index, I want my page to contain the temperature is 21 Celsius. This is based off of this model of the domain, all right? This user interaction. So far, so good? There should be nothing surprising here so far. Anything surprising? It's just thumbs up. Good, good, good. Shout out, please, if there's anything surprising, anything that you want me to go back through. Okay, so let's see this test fail. Clearly something's happening here, so there's going to be some issue with syntax. Let's double check what's going on. Because that's not how you write. What did I do? It looks a little bit better. Cool. Okay. So we have a failing test. We managed to get the app element, but it made it an assertion which failed that it doesn't contain temperature 21 Celsius because clearly we haven't made any of the requests yet. Okay? So this test is failing. Great. Is where I want to begin. A quick point to remind you all: if you want to make sure you have the right port number, add to your configuration for Cypress the base URL where all your requests made from. Sometimes it understands which one to use, but if you want to make sure, just be explicit in your config and add the base URL. Careful of the uppercase U. Some people miss that out. I think I didn't actually leave it there because I wanted to make sure people did it themselves. Did I include it here? No, it's empty. So make sure you add it if you want to specify it. Sometimes it's not necessary. Okay, so failing test. Now I have to figure out how to parse it. So this is our HTML file. What is it doing? Line 6 requires some JavaScript, the JavaScript library jQuery. All this is some JavaScript. So if you can actually go have a look at this location if you wanted to. It's just a bunch of lovely, lovely text. Look at that. It's .min up here at the top in the browser. There is the process called minification. All right. So if we actually remove that, it will give us a little bit better formatted. So if you wanted to spend your time reading this, you can. I don't recommend it. Maybe it's bedtime reading. Who knows? It depends what you're into. But all this is to say is this is simply just a resource that people can load into their own programs. So it's available for use. The only thing that you have to remember is that you have to have internet connection to access it. So you couldn't run this program without an internet connection. If you wanted to, you'd have to take all this code and whack it in one of your own files. Imagine, say, for example, you had a new file called jQuery. Cool, it's about 10,000 lines long. So if you want to go down that road, yes, you can. And then you could link internally to this and therefore not worry about an internet connection. All right, depends on your approach, it doesn't really matter. I'm not including it just to keep things very simple. But it's just JavaScript at the end of the day, all right? jQuery is just JavaScript. So I just require some JavaScript, and I have one element here that I want to change. So this is the text I want to change with my application once I load it, and it loads on line 13. So I've got this index.js file, that's going to do the work for me. So go here, and this is where I need to do some stuff. So this is where I need to make a request to the API and then update the app element with the right temperature. Yeah. So far making sense? Any questions so far? Cool. We're gonna run it once with the actual API request happening, and then we're going to see how we stop the request. I don't want to double check. Okay, I have loaded jQuery first, so I'll have access to it when this script loads. So we can do something like $get, and then here's where we have to pass in that URL. Where did I send you? Where did I use it? Something like this. I imagine we might need, let's do it that first. Okay, so this is my URL, and then I have to pass in a function that then document get element by ID. You probably could use jQuery for this. What's it called? It's called app, right? So we grab that element and then we update this element. Inner text is equal to, what does my spec need it to be? The temperature is something. I need to get the data back. So if I want to use the data from my GET request, I have to make sure I pass in an argument here. Let's call it data. Let's have access to it within the callback. I want to be able to extract data from it. Now, in the request that I've already sent, let's double check what it looked like. Can't remember anymore. In the response that comes back, I want to access the temperature. The temperature looks like it's this one here in some weird number, 294. Why is it 294?
It's Kelvin.
It's Kelvin.
Imagine, yeah, okay. So I think the default, why did I do that? I think the default temperature is Kelvin. I guess I could send across, let's do Celsius, because no one's got time for that conversion. Can I just add it, please? There we are. All right, we've converted the temperatures to Celsius. All right, it gave me the way that I did that. Let me just quickly is it looks like units of measurement are default Kelvin, but if I want to change it within the response, I can just add a key value pair into the query string. And the way that I did that gives you an example here is you just add a key and a value metric. Key is units. So in here, I just added and units equals metric. As a result, I get back temperature in something a little bit easier to read. All right. So in order to get the right part of this, it looks like the first key I need access to is main, and the second key I need access to is temp. Let's have a look at everything first, console log data, and then I'm going to have a look at data.main temp. Let's have a look at both these things. So when I do my console.log statements, I'm making my request. As soon as this gets loaded, this JavaScript file gets loaded, makes the request, and the callback function then executes when the request resolves. Actually, don't need to for the moment. We'll do that in a second. I just want to see what the response is, and can I get the temperature? Can I extract it from that response that comes back? Let's just Oh, what's going on? It doesn't like my JavaScript. Hold on. Let's make it a little bit easier so I can see this. It probably is an issue with my malformed URL here. So let's add in maybe something like that. It doesn't see this.
Do you need the S in HTTP?
Try, I don't think so. It's not picking up a version of it. So let me reload it. It's not seeing it. Have I saved it? I have saved it. So let's kill you. You don't get to live anymore. Now I bring you back to life. And there you are. Now it appears in my browser. All right. If you make any changes, sometimes you might need to reload your server to pick up any new file changes. All right. So remember that might be something that gets you. Kill the server just by aborting it, Control-C, or however you abort your current process to stop it, and then you can run it again. The reason I spotted that was like I was making changes and I was looking at the sources tab up here to be like, what is my browser seeing? Because that is as close as possible as you get to knowing what's happening. So if I go back to the console here, I can see the information that's come back. This is the response back from the API call. All right, in exactly the same way that I was sending the request from my command line. I've done it in the same way using jQuery's get method. All right, and now I have access to it. I clearly didn't send it with the units metric there, so let's go add that in. And I'm going to have to go through this process and killing my server every single time. Fun. Cool. So we can see here that we get the value that I want. All right, this is the Celsius value and this is the object. So if I want to see this on the page, the next step here is grab the element from the page that I want and update its text. All right, I want to update it with this value here. So we could just do something like this. I need every change, kill, run. I guess this is probably why I was using the serve, because it will probably keep checking, updating for packages. Anyway, something for a different version of this. For the moment, you'll probably have to keep killing your server, running it again. Cool. So the temperature is 21.57 Celsius. So what we've done so far is make a request from our JavaScript using jQuery, find that element on the page by the ID of app. I'm going to get rid of these because we don't need them anymore, and update the inner text. I know it's got an ID of app because in the HTML it has the ID here. So if I go back to my Cypress test and try and refresh the page, it doesn't see it at the moment. It doesn't see the temperature is 21 Celsius. I am wanting to change this. All right. So what we need to do is find a way to stop the request that happens. But at the moment, I actually want to see it happen because it's not changing here. So let's restart the test just to make sure, because what I want to do is see it happen. Cool, that's what I wanted to see. So this is the actual request that's happening within my test, and this is not a good thing. Remember what we were saying about tests. They should always be reliable, they should always be consistent, and they shouldn't change depending on other variables. So this is currently violating our principle of how we want tests to run. So as a result, we've got to find a way to control this behavior, control the response that comes back from this API. And the way that we do this is by stubbing the request. Now, Cypress gives us a nice, easy way to do this. And it's as simple as adding in another Cypress command to make an intercept. And the things that we have to, the way that we have to use this method from Cypress is we give it a URL to check against any requests being made to it. So we can go grab this from our JavaScript, any requests that happen to, let's say, for example, this endpoint. And I'm going to add an asterisk here at the end of it, which is important to say any request that matches the first part and then anything else afterwards. The second argument is, well, what is the response we want to send back? And the way that we describe that is by using a key value pair. An object has a key value pair called fixture, and then the file path to whatever is the start response that we want. So in this case, what I want is to add a file into my fixtures folder and give it a name, something that is descriptive, and add the response here. And so where do we find the response? Well, we can find it from one of the requests that we've already sent. So I can grab all of this and whack it. This is essentially a version of a real response, but I'm just recording it here and saying, I want to use this response in future rather than a real response that comes back from the server. And here I say, well, let's just change this to be 21 degrees. All right. So now this is hard coded to be always 21. And in my weather spec, I have to give it to the right file path. It's always relative to the fixtures directory. So we pass in here weather london.json, like that. So I'm going to intercept any request made to this URL. I'm going to stub the response using the JSON in this file. So then when I make a request to the index, I should be able to always consistently get the same temperature. And then we have a test that works. So the stages usually involved is making a real request first, just to understand what is the response. Sometimes you don't have access to that. You can rely on the documentation for the API and what like a response looks like. And usually they include some kind of example. Do they have an example? Yeah, they do. So in a pinch, you can always try and use an example from the API if you don't have access to your own key or something like that to test against. So this would also work. Grab it from one of the examples. You add it to this fixtures folder. This is all Cypress saying it wants you to put any fixtures in this folder, and it will look it up when you use the intercept command, and so or it keeps it a little bit tidy for you. And then it will listen to any of those network requests and say, if it does match this URL, then we'll stub it with this response. And therefore, we're not actually sending the request, and we can control in future what it looks like. The problem with this is then if the API does change and that response does change, we'll have to then make sure at some point we do run a real live test to make sure nothing has changed. But we want to be careful with making sure our tests are always running in a consistent manner. Cool. So this is what I want you all to go back and do yourselves, and just get into this practice of making a request in API, making sure you understand what the response is, storing it as a fixture in the fixtures folder, writing your spec to intercept that request, providing the fixtures as your stub response, and then making sure your test passes consistently. Questions? Does it make sense what you're going to do? Sorry, yeah, go ahead.
Yeah, sorry, I have one question.
Yeah.
When I run the curl on my terminal, and since there's so much information on it, on the URL about the weather, they'll like suddenly go ... and it won't give me the whole content of the file. How do I make it give me the whole content of the file?
So you could, what you could do if it's doing something like this, but it's not completing, it just has ... Is that what you're saying?
Yep.
Another thing that you could potentially do is use like a greater than sign to say, let's go to a file and just pipe the result of this command into a file. So it would then look like here. It would just give you everything into the file.
All right.
So it won't display on your terminal. It will then take everything, all that data, and throw it into a new file.
All right.
All right. So this is a replace. It's not an append. If you want to append to a new file, you can do the double equal greater than something like that. That appends doesn't remove. It's not destructive. It's only additive. So that's one way you can do if you're always limited by the screen size of your terminal shell, things like that, is just send it to a different destination rather than your terminal. All right. And then if you're in your terminal, if it still is like badly formatted as this, you should, a nice idea is to find a package for your editor, something called Prettifier. So if you have it, you will be able to have access to a Prettify command that then automatically formats your JSON, which is nice and useful. It does a lot of formatting for you. So whatever you're on in your editor, just find a way to go to your settings and install packages and go install something that's called I may already have it. I think it's Prettifier, something like this. Yeah, it's probably this one. It looks like I need to install it. So I wonder which one I do have. Hold on. This is absolutely irrelevant. I have this one. It's called Pretty JSON. So maybe that would be something that you can find for your editor. All right. That just helps just quickly format so you don't have to worry about reading it yourself. And there's a bunch of online tools as well. So if you don't worry about it in your editor, you can try and find JSON Prettifier. Yeah, you probably just whack it in here and then do it or something like this. There's loads of tools out there, right? If you can't be bothered to do it for your editor. Back to questions to make sure we know what we're going to be doing for this next 45 minutes. Yeah. If you do that first one, then your sort of extension to this is find a different API. You might even want to find a different endpoint to the Open Weather API, and then design a quick update to your application that uses data from it and test drive it in the same way. So figure out what you want your page to look like with that information, write a spec for it using Cypress, and then test drive it. This link is, I think, a link to a bunch of public APIs that you might want to randomly explore. News. Grass for coronavirus. Coronavirus, 2-letter country code for China. Look at that. Anyway, no questions? Everyone, give me a thumbs up if you know what you're going to be doing. Cool. All right. Enjoy and be back here at 4:15, 4:15, all right?